Hi everyone, in this video I want to work through another application that will require us to solve an exponential equation. So this one is a little bit tricky just because we aren't given the information for a growth factor for free. We have to do a little work to get it. So what we are given is that the value of a home 4 years ago was $240,000 and it just sold for $290,000. We're supposed to assume that its value is increasing exponentially and continues to do that. And we are trying to figure out when the home will be worth $500,000. Okay, so first thing, we do need to find the growth factor. How much did the value increase by over the 4-year period or over a 1-year period? But 4-year period is easiest for us to find. So I would just say if we want a percent increase, we started at $240,000. And we're trying to figure out what we would have to multiply that by to end up at $290,000. So this is just a division. Oh, we can actually knock out a bunch of zeros. So 29 over 24. About 1.2083. I'm going to keep that many decimal places. I don't know that I need them, but 0.83. Okay, so this is my base, and basically this is telling me that in in 4 years, the value of the home increased by 1.2, a factor of 1.2, so 120%, 20% increase, almost 21% increase in 4 years. So if I want to set up an equation for this thing, I would say I started at 200 and, let me think about this. When will the house be worth $500,000? I'm going to start at 290 so that my starting year is now, and I can say how many years from now it will be worth 500,000. It would be okay to start at 240 as well. You'll just have to then word your answer as from the original purchase, how many years it takes to get up to 500,000. So I'm going to start 290 and say I need to multiply by 1.2083 every 4 years. So this is a t over 4. And I'm interested in when that will get me up to 500,000. Okay, so there's my setup. The solve is going to involve a division again. So 1.2083 to the t over 4 is equal to 500,000 over 290,000. Once again, just to save the writing, I'm going to cross out a bunch of zeros. I am not going to switch to decimals until the very end. I do have a little bit of rounding. I don't want to work up more and more and more rounding. Okay, so I'm going to next take a log, and I'm going to use the common log. It doesn't matter, but if it has to get plugged into my calculator eventually, I'm going to choose one of the two that are easy to plug into my calculator. If it's really easy for you to choose a different log and plug it into your calculator, go for it. Okay, so log of both sides. I can bring the t over 4 down to the front. Let's see, next I'm going to do both of these at once. I'm going to multiply by 4. So I get a 4 log 50 over 29. And I'm going to divide by the log of 1.2083. Okay, and then I'm going to plug that whole mess into my calculator. So I have a 4 times the log, the common log button is right next to the number 7, of 50 over 29 divided by the log of 1. And you know what? I can even do one better. I still have this number sitting in my calculator, so I'm just going to arrow up and use that whole thing. If your calculator won't let you arrow up, you could try second and then this thing right here, second, and then the minus sign on these TIs gives you A and S, previous answer. Otherwise, you can type in the 1.2083. We're just trying to save up our rounding error as much as possible. So I got about 11.51. So I'm going to say 11.51 years from now. Again, if you had chosen 240 as your starting monetary value, that would just mean that your starting time was 4 years sooner. So you would have gotten 15.51, and you'd say 15.51 years from the original purchase of the home or something along those lines. So you get to decide what that starting value is, and then you just have to make sure you stick with that and give all of your answers in terms of what you chose. All right, thanks for watching.